So I know we do have a couple of new folks on the line here. Not intending to put people on the spot, but wanted to try and just, if you don't mind sharing your name, your username if you provided one for the challenge, your school and major, and if you're looking for a team, because we do know that there are folks that are on our list that are still looking for teammates, and we do have a way to set that up. But over to the participants in the webinar. And maybe what I'll do is I'll just go off the top of my list here, starting with James.
All right. So my name is James. I'm actually not a student. I'm a software engineer at Microsoft, and I was like the EVP at SASE at University of Florida, though. Not doing any challenge or any team. I'm just really interested in the topic. So I'm glad to be here.
Awesome. Thank you for joining us, and welcome. Kelly?
Hi, I'm Kelly from SASE. My major is CSE. I have a partner, but personally I'm open for joining other, it not just being the two of us. So, a fun fact about me, I draw. So.
Any particular types of drawings? Like, is it like cats or like anime characters or like certain like Marvel people?
Okay. It's anime characters when I'm not in a school setting.
Very cool. Well, welcome. And that's good news about the teams. So we will talk about that a little bit. There is a Discord channel set up to meet people. So we offer that, and we'll talk through that a little bit later. And then last but not least, Tiger, if you don't mind introducing yourself as well.
Hey everybody, my name is Tiger Chen. Welcome back to me. Glad to be back, rather. That's what I meant to say. I am also not a student. I'm a software engineer at Northrop Grumman, being a cyber software engineer, and I have an idea, and I guess quick question: if people want to go solo, is that an option?
So that is something we're exploring based on the way it's set up now with the list. It seems like there are a large number of people that are looking for teams. So we are going to explore that as an option, and we will be getting out word about that. So great question.
Okay. Cool.
Okay. Well, just to recap, we have been on a summer learning pathway since July, and this was totally optional, but we wanted to provide a means for people to prepare for the ultimate challenge, and we did it along sort of two tracks. There's a self-paced track that we've had that's just been the Unity's essential 3D training just on the gaming engine, as well as a couple of modules on diversity, equity, and inclusion, just to give some topical foundation on the issue. Then we've been supplementing them with these webinars. So our last one was one on diversity, equity, inclusion, and storytelling, and the ones prior to that have all been sort of a technical focus, and we're back in the seat with the rapid prototyping and trying to get the participants in the game jam oriented to the challenge, and how do you get started and move quickly. But as a part of that, we've had some perks, and as a reminder, this is a partnership between us, SASE, Unity, Boeing, and Dell. So everybody is chipping in on this, and I think one of the big prizes, the Alienware laptop, I actually just picked it up at the office the other day. So this is it. It's definitely legit and real, and it is based on the Leaderboard, which is our next slide. Let's take a look at that. So it looks like Stringing Access is still in the lead, giving people a run for their money. It is never too late to complete some of these challenges to get points and put some numbers on the board. We are going to be doing the drawing for this next webinar session. So on the 30th, we'll be doing that. Next slide. So how do you earn points? If this is your first time coming to Game Jam, these are all the different ways you can earn points to get on the board here. This is also posted on the landing page, and we'll make a note to send this out to the team again, just so that everybody has it in their back pocket. But what you do is you can go back, you can look at any of the modules, you can look at any of the webinars, and submit your activity completion to the email address at the top banner there. Okay, moving on to the next one, the challenge itself. So that is on the 2nd to 3rd of October. And we are looking at opening up to solo participants and also looking at the time frame in light of some of the changes, right? So SASE this year, the national conference is going to be virtual. This is entirely virtual, and we recognize that that can be challenging for teams as well. So we are going to look at expanding that time frame a little bit so that it isn't just 24 hours, but the 2 themes remain the same. So the first theme is really around, you know, how do you bring awareness to Asian Pacific American challenges that our community faces? And then the second one is a little bit broader, is how do you become a better ally? How do you communicate, you know, allyship within and outside of the community? They're intentionally broad because we want you guys to use your imagination and your creativity to come up with your different submissions. And then the prizes are as follows. But we are looking at a registration deadline, no matter what, of 11:59 p.m. on the 30th, which coincidentally is the day of our challenge review, the last webinar. And as far as the submissions go, we're going to be using itch.io as the platform and do have a detailed scorecard that we will walk through at the next session, just to give folks an understanding of what the judges will be looking at for the submissions. If nothing on this one, I think we'll move on to our main topic of rapid prototyping and starter projects. And again, we have some really awesome speakers here from our own Immersive Studios, our own experts. We have Kevin Kingsbury and Zachary McPhink, who are going to talk us through. And what we're going to do here is we're going to kind of start really high level, right, around prototyping and that process. And then we're going to drill down into some practical things you can do, some starter projects you can get into yourself just to, you know, get ready for the challenge and get yourself in the mindset. So without further ado, I'm going to turn it over to Kevin and Zach. If at any time you have questions, I encourage you to use the chat feature or just raise your hand and ask them, and we'll make sure that they get addressed. But thank you for joining us, and I'll just turn it over to Kevin.
Great, thanks for that. Hi, everyone. I am Kevin Kingsbury. I am essentially a DevOps engineer for Booz Allen Hamilton, located down in Austin, Texas with Zach. Yeah, I actually spoke, I think it was like 5 or 6 years ago at the other SASE conference that was in Houston. And that was an interesting one where I gave a talk basically on containerization and Docker and essentially how to get started using Docker. And there was that particular challenge. It wasn't necessarily a game jam, but it was more around kind of like rapid prototyping. And the teams on site in Houston came up with like wonderful ideas of, you know, putting together devices, sensors, information like that. And we were using little, you know, embedded hardware pieces like we were using the Intel Edison because Intel was a sponsor. And I don't know if anybody remembers the Intel Edison, but it was one of those kind of early devices. It's kind of not around anymore. It had its own advantages and flaws, and it was just kind of overtaken by some of these other devices. But that was about 5, 6 years ago. And the way that my career has been, I've kind of had this interesting take where over the last 10, 15 years, you know, I started in DevOps, you know, back then, things were a lot more different than they are nowadays. And it was a lot of this rapid prototyping, the advances of technology, and just kind of the building blocks of all these pieces that kind of just changed the field and just made it different than what it was when I started, you know, 10, 15 years ago. So I kind of wanted to hit a lot of those highlights from like a hardware standpoint, from a software standpoint, and even from a skill set people standpoint. And then at that point, I'm going to turn it over to Zach. He's going to dive in a little bit more in detail. He's going to go through some Unity specific stuff. He's going to do a demo, going to do some more hands-on kind of stuff that will be useful for you and your challenges, while the information that I'm going to be giving is, you know, a lot more historical, a lot more overview, and hopefully just kind of gives you awareness of, A, how the field has changed, and B, just kind of what's out there for everybody to use. So with that being said, next slide, please. Oh, and the other thing I'd like to note too is I'm hiding in my back guest room, so that way if dogs bark or if the toddler runs around screaming, sound is kept to a minimum. However, that also puts me probably the farthest point from the wireless access point in my house. So if anything, starts to go wonky and I start to drop, there's ways to mitigate that. I can, cut video and we'll figure it out from there. So holler if we have any issues, and I'll go from there. So cool. So we're going to start a little bit with what I talked about before, which was embedded devices. So what you see here is kind of essentially a loose timeline of what happened over the last 15 years or so. It's definitely not exhaustive, but these are kind of some of the big milestones that have happened in the field. So back in 2005, obviously the big change was essentially the invention, I guess you would call it, of the Arduino. The Arduino is a microcontroller. It is not a computer. It is a chip that you can essentially program, and since you can program a chip, you can have that chip do all sorts of things. You can have it interact with things. You can have sensors. You can have buttons. You can have displays, all sorts of feedback, user feedback, that sort of stuff. But it really lowered the bar on some of this kind of rapid prototyping. Of course, it brought microcontrollers into kind of the hobbyist field, and essentially down into like the end user and the consumer. The Arduino boards themselves, you can get it on like these kind of dev boards where they hook up to USB and all that, and they're not very expensive. They can be like $20, $15, $30, whatever. But the actual chip itself, which is that kind of microcontroller that you're programming, those run as cheap as $5. So it really lowered the bar to be able to suddenly have the hobbyists be able to start interacting with sensors and devices and be able to just kind of do all sorts of things that their imagination had. So then we kind of move over here to the lily pad, which is an interesting one that I wanted to note. This was a couple years later, and the lily pad, obviously is a smaller form factor. And one of the interesting features of it is that it allowed people to essentially create wearables. It put that microcontroller inside fabric or on some kind of harness, or basically inside fabric. So out of the gate, that had huge implications for like the cosplay field, where people could create all sorts of costumes that had lighting effects and dynamic interactions and all sorts of motors and motorized things, as long as they had the battery power for it. And then at the same time, you had wearable devices and fabrics that you could then throw in the wash, and they were protected, and you didn't lose the hardware or the electronics because it got wet. So that was a cool kind of change. And then obviously the next big player was in 2012. You have the introduction of the Raspberry Pi. The Raspberry Pi, unlike the Arduino, is a full computer. And when it came into the field, it was a full computer at basically $35. Nowadays, since there's a chip shortage, they're a little bit more expensive, and you can get ones with more memory, or the newer versions have a little bit more horsepower. But you're talking, you're still kind of in the ballpark of $40 for a full computer, which just lowers the bar for compute for people across the globe. It just made it so it was very easy for people to get involved with Linux, to people to pick up a computer, attach a keyboard and monitor, and be able to just kind of hit the ground running, program. And same kind of thing, they could build stuff because it had these GPIO pins. You could hook it up to sensors, motors, whatever you wanted to kind of build the things that you wanted to build, or what you had in your imagination. And then the last one here that I kind of wanted to talk about briefly is more of a newer development, which is the Nvidia Jetson. The Nvidia Jetson has these kind of these GPU chips built into the board. So unlike the Raspberry Pi or the Arduino, this is lowering the bar for prototyping around basically computer vision. So anything where you're doing object recognition, object tracking, those kind of AI concepts, the Nvidia Jetson can handle those. And same kind of thing. It's a small form factor. It doesn't take too much power, and you have this kind of lightweight, low power chip that has a lot of horsepower and then can do a lot of things that used to be very difficult back in the past. So next slide, please. So after we have these embedded devices, these embedded devices have also kind of led to other developments. One of the cool kind of things is things like Arduinos and Raspberry Pis. They're built into a lot of these other kind of devices that are out there that help with rapid prototyping. And this kind of side, we're talking mostly about fabrication of like, okay, I want to, not only do I want to build something, but I want to build something quickly that, has some sort of form factor. And that's where things like CNC machines, 3D printers, laser carvers, and engravers come into play. So for those who don't know, a CNC machine is essentially it's like a computer controlled saw or drill. It allows you to take materials like thicker materials like wood, and even metals, and just kind of carve things out, which would be very difficult to do by hand. You can, use these 3D programs to create images, create templates, create engravings, and then you can have the machine go do that. 3D printers, I think pretty much everybody out there should probably know what a 3D printer is by now. A lot of the ones out there on the market, like I said, run off of Arduinos, run off of Raspberry Pis. There's a lot of, kind of build your own that do that, which is very cool as well. And then the last one is kind of laser carvers and engravers. These are a little bit newer. These are also a little bit more expensive because the lasers are expensive. But same kind of thing. It allows you to use a laser and essentially carve something out. A lot of the times you'll see these, they'll cut through thin materials like acrylic, some of these kind of thinner woods, thinner veneers. So you can make things like, I don't know, like phone cases and, these intricate art displays that use kind of thinner materials. You're talking materials that are, probably, under a half inch. Like that's pretty much the limit of the lasers. If your laser is doing too many passes over a material, it could potentially catch on fire as well. So that's when you switch from like, a laser carver over to something like a CNC machine. But between those three, there's other examples out there as well, but that allows you to kind of build a lot of the things, to help with your rapid prototyping. Like, you're building a harness, you need some custom components to house that. You need some sensors, you need some housing to protect it from the elements, to protect it from this or that, to hold things in place. You can use any of these. You can use one of these, you can use all of these to kind of to help facilitate that process. Next slide, please. So now we're going to switch a little bit from like kind of the hardware standpoint to the software standpoint. So back in the day, when I kind of started my career, virtualization and moving to the cloud was kind of the big thing at like, the end of I guess they were called the aughts. So like 2009, that was about when Amazon Web Services came out, and suddenly everybody wanted to get out of their data center and they wanted to move to the cloud. And that was good for businesses, but that was also good for hobbyists, that were good for, these people who were trying to do rapid prototyping out in the field. Back in the day, if you needed like a server, it took a long time to get a server. You had to talk to the IT department. They had to like figure out what you needed, get the specs together. They had to, find something from Dell or HP or, even companies that no longer exist like Gateway, and, come up with kind of the specs for that server. They had to talk to purchasing, get the PO, get that purchase order in so it was paid for. Yeah, Tandy computers. That was the first computer I had, was a Tandy back in the 80s. So exactly that. Back when there was this place called Radio Shack and you used to go there to buy computers, But all that took a while, and it took basically, it would take like anywhere from like a month to 2 months to like essentially get a server. And then once you had it, you're like, okay, I'm gonna throw my software on it, or I'm gonna try to build out this thing that I'm, this prototype of something that's gonna work or isn't gonna work. And then there you are. And if it doesn't work, then suddenly you have this expensive piece of machinery sitting around that, finance is like, you made us buy this, now you don't need it, what the heck. So the invention of the cloud, and especially things like VMware and virtualization was like that first stepping stone. It got people, first excited about virtualization, understanding virtualization, so that when it came time to move to things like the cloud, like AWS, they understood how it worked. They understood how to do it. And AWS was, the first one out of the gate. They've always been kind of the leader with, they have something like 300,000 features now, and you just can't keep up with all the things that they're putting out. And they have things in AI and machine learning and natural language processing and big data and all these huge kind of big problems that, say you're working on something that involves a genome of like a rat, like suddenly you can take that rat genome and you can throw it into the cloud and have access to that data, manipulate it, do what you need to do to figure out the next steps in your prototype, the next steps in your project. And it costs you, pennies on the dollar or just a couple of dollars to run those analytics, where in the past, that was months worth of work. That was, getting all that equipment in, loading all that stuff onto the machines, getting those machines. It was usually clusters of machines, getting those clusters talking to each other, all of that like headache and heartache. And now it's just like click, 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 and suddenly you're like good to go, which is really cool. It's also can be really dangerous, where you can run up a bill for your company or even on yourself very quickly by being like, oh, I didn't lock this down, and now somebody's Bitcoin mining off of my account. Or I was doing this big data project and I spun up all these GPU machines and I didn't understand the cost structure, and suddenly now I owe AWS like $6,000 for a couple days worth of work. So you got to be careful with stuff like that. But as long as you understand it, you do the trainings, you have a Sherpa to kind of help guide you along the way. Then everything, going to the cloud is not scary, and it allows you to do things so much quicker and figure out whether something's going to work or whether it's not going to work from a software standpoint way quicker than it used to be in the past. So it's definitely a wonderful advantage that of all the things, like it was groundbreaking, just like the invention of the Arduino and the Raspberry Pi. It just shifted the field, and it just kind of changed everything. So the virtualization was just a huge deal. Next slide, please. So after we could do this software stuff very quickly, there was a lot of other things that kind of came along and built on top of that. So you hear things like CI/CD, which is continuous integration, continuous deployment, and you hear things like infrastructure as code. And you hear things like Docker and Kubernetes, which is containerization, which is different than virtualization. It's just a different technology, but same sort of thing. It allowed you to get to software, and it allowed you to get to writing code that much more quicker than having to deal with hardware and software and all those other things. So we could easily spend a half hour just on Jenkins alone and how useful Jenkins is for building pipelines and all that. But unfortunately, we don't have that kind of time. So we're gonna, mention Jenkins, that it's just a wonderful tool for building CI/CD pipelines and just doing automation in general. And once you get started with Jenkins, it really becomes like that hammer, and everything looks like a nail. So you have to be careful with that, where you don't apply Jenkins where it may not make sense. But once you understand how useful it can be, it really becomes one of your best friends of just helping to just, push things through a pipeline, get that repeatability, get that automation to really just help move your project along. And because I'm a DevOps engineer, That's why I mentioned things like Chef and Ansible and Terraform. Those are near and dear to my heart. Instead of, spinning up servers like I did in the past of, getting that hardware and then taking a CD and going from computer to computer and building things that way, or USB disks, Chef, Ansible, Terraform, that just allows me to just spin up code, or to use code to just spin up infrastructure. Terraform allows me to configure those clouds, whether it's Amazon Web Services or Google, and then Chef and Ansible allows me to use things like Jenkins to work with, within each other to build those pipelines, and have one kick off for the other, to just configure machines and get that repeatability, get that uniformity across the environment, so that my dev environment matches my test environment, that matches my prod environment, which as a DevOps engineer or anybody who supports operations, that's always key to any successful software development project, is making sure your environments match, so that people have less barriers to entry, and they don't run into problems when they go from environment to environment. And the automation allows you to do a lot of extra things that can be kind of annoying, like auto-generating documentation, running security scans, these packaging things up and kind of publishing them. Some of these tasks that we don't like to do, but are necessary, especially in big organizations, to make sure that everybody's working together and playing together nicely. Next slide, please. Yeah, so continuing along the theme of software, we're going to move a little bit away from like my field, which is the DevOps field. And I'm going to talk a little bit about software development, but because I'm not a software dev, I'm not going to go too far out of my swim lane. And I'm just going to mention that, there are frameworks out there like Bootstrap and Django and React.js that just once again change the landscape. And instead of everybody having to recreate the wheel every time they built a web application, it just allowed you to do things much quicker and get to those MVP stages that much faster. Bootstrap allows you to kind of do some HTML, CSS. So it's how you kind of get that look and feel, how it interacts with that UI, UX. Django is just an example of a Python framework that's very popular out there. A lot of people like to use Django for web apps. It's very popular out in the startup world. And then React.js is, I believe it's just essentially a framework of Node.js. Once again, starting to get a little outside my swim lane, so I'm not going to go too far out there. But, same sort of thing. If you need those CRUD operations, which is like create, update, delete, and I don't remember what the other one is, but doing those things like adding things to a database, making user records, having a user log in, the same kind of functionality that every web application has, these frameworks, they have it built in, so you can just roll them out and just a couple clicks of a button or a couple commands, and then suddenly you have that in your application, and you don't have to sit there and spend hours rebuilding that from scratch or writing that yourself. You can just kind of deploy it. So that's web frameworks, which are also super useful. So we'll go on to the next slide. Yep, so this is the kind of the Agile Devops slide, and this is kind of my last slide before I hand it over to Zach. And this is how we kind of switch from that software standpoint to essentially people. And if anybody, I'm sure a lot of you have heard of Agile development. It's relatively new. I mean, within like the last like 20 years. I believe it started in the auto industry with like Toyota and all that, where Agile development is essentially this closed loop cycle of doing things faster and essentially failing faster, and then learning from your experiences to improve and move forward. So rather than taking 3 months to build like an MVP, you take your project, you build it, you break it into little chunks, and then you start hitting these little chunks quicker, and then you can figure out faster whether things are going to work or not, or then if you make a mistake or if something's broken, you can get that feedback cycle into your development cycle that much quicker, rather than rather than, you know, ending up like if we all remember the healthcare.gov fiasco from a couple years ago, where they built this huge web application and then they turned it on and people went to go use it and it just fell over. Where, you know, that was the result of not doing things in an agile way, having, you know, way more contractors in the kitchen than you needed. But if they were following an agile development process, that web application, they would have done smaller pieces, they would have been testing as they go, and, you know, they would have learned that it was going to fall over a lot quicker than when they went and turned it on. You also see that GitHub is mentioned here. GitHub is a little bit of a unique one where essentially GitHub and Gitflow, it's basically checking in code, and it's a way that developers learn to interact with each other and work together even though they were disconnected. So developers who are not in the same room, disconnected teams across geographies, time zones, whatever, you know, by following Git flow of doing these pull requests and checking code in and doing these bite-sized chunks, it allowed these teams that were separated to get a lot done, not step on each other's toes, and be able to work together and get these MVPs done very quickly. And then these last two once again are near and dear to my heart. You know, it's the Devops cycle, and then what is also known as the Devsecops cycle, where the Devops cycle, you know, is that kind of implementation of that agile cycle of, you know, you're deploying things quickly, you're testing things, you're using automation to figure out if things are going to fail. If they're not going to fail, then you push them out to production as fast as you can. If they're going to fail, then you kind of give the developer or the user feedback of why it's going to fail. It allows you to have a faster cycle. The DevSecOps is just this like different variation of it where they're like, oh, we need to include security. And the only reason I kind of call it out and mention it differently is that there's a bunch of other things that you can replace that security with that still makes sense. Like you could replace it with finances. You could replace it with like the human aspect, and that whole cycle of planning, writing, you know, testing, releasing, monitoring, you know, is still the same. And, you know, you have the same kind of feedback loops, whether it's from a security perspective or whether it's from a financial perspective. It just depends on the goals and what is important to each of the people. But those things like DevOps, Agile, Gitflow, it changed the way people thought about things. It definitely made those pipelines and workflows a lot shorter, and it took the time of getting these MVPs and reduced it dramatically. So it was once again, you know, the agile methodology was a huge development in changing the landscape for rapid prototyping. With that being said, I'm going to now hand things over to Zach. He's going to take you through some stuff in Unity. In Unity, same kind of thing. It's this wonderful software program that allows you to do games, 3D sorts of things, where back in the day, you needed expensive software to do that. You needed something like 3D Studio Max or these other things that cost thousands of dollars. And nowadays, you can just download Unity for free. Someone like Zach walks you through demos, or there's these online demos, and suddenly you're doing things that are just super advanced. So thanks everyone, and Zach, take it away.
Awesome, thank you. Hello everyone. So my name's Zach. I've been working professionally as a Unity developer for a few years now. I started as a VR developer specifically, before moving on to Booz Allen Hamilton, where I'm more so focused on quick prototypes, rapid prototyping. So there we go. Game plan for my portion is we're going to do a quick breakdown of how to get a Unity starter pack, how to access it, edit it, and follow the tutorials. And then we're actually going to go inside of Unity with a demo of how to add a feature to one of these starter packs. Unity developed these starter packs as a way to help users learn how to navigate Unity, specifically how to change variables of objects, such as in the karting example, you can change the top speed of vehicles. And by the end of this talk, you'll see like all the advantages of using them, not just for junior developers, but even for mid and senior level developers who want to maybe buff up their portfolio really quickly. But to find your preferred starter pack, you're first going to go to the asset store on Unity, which you can see the link there. It's assetstore.unity.com. You're going to go to the top tab that says Buy Unity and click on Templates. This will show all of the Unity made templates they have. I suggest choosing one of the few that say micro games as your first one. These were specifically made with really in-depth tutorials for true beginners, and I think the three of them are an FPS one, a 2D platformer, and karting, which for my example I chose a karting micro game. Once you find it on the page, you'll click on it, and on the right side of the screen you can see underlined it'll say what Unity version it supports. So that's all we have to do there. You don't have to add it to your assets. We're actually going to do that on the next slide. So you'll download Unity Hub. If you have Unity and that you just installed a basic version of Unity, I really recommend going and installing Unity Hub instead. This is a great source to track all of your projects from one little application and have all their versions set nice and tidy. You can see in the middle image I have typically 10 to 15 projects on my PC at any given time, and they're all different versions for specific reasons. So it's really nice for organization. But you're going to go to unity3d.com, get unity/download. You're going to click download Unity Hub instead of a specific version. And then once that installs and you open it, you'll see the middle screen. You can go to the left and click installs, and you can install the version of Unity that is supported by your macro game. Typically, I use 2020.3.10, but that's just because that's the latest I've downloaded that I've needed access to. Finally, step 5, once you actually have everything downloaded, you want to create your project, you're going to click on a little arrow next to add, and you'll be able to choose which version you want to open the project, create a project in. Once it loads, you'll see all these little templates, all these little cubes. You can choose which one you want to install. So you can see in the picture, I actually have karting macro game. I clicked install. I named what I want to name our project, and I chose where I want to save it. Once that's done, I just hit create, and we can go to the next slide. Okay, so inside of Unity, once you start the project, on the right side of the screen for these starter projects is a tutorial section. You can go through this starting at the top tab that says Get Started, and you can work your way down all the way to the last two, which is introducing mods, which are pretty much you finish the tutorial and you can go and add even more stuff that Unity has created for this specific project. You can, once you are in the tutorial, there'll be like little navigations, really cool UI elements that show you how to change everything. It'll show you like how to start your project, how to change different like textures and things like that that are pretty basic and essential for the project. You don't have to go through them if you've been through these before, but I really recommend it if it's your first time in Unity or you're still new to Unity. I recommend going through it. But once the tutorial is complete, you go to mods, you can go through here, and as you can see, there's all kinds of stuff, including like environment updates. There's some really cool like unlockable system for costumes. There's AI. There's new game modes. Like there's one where you can hit bowling pins down. And these are great for expansion of what you've learned during the quick tutorials. Yeah, we can go to the next slide. Awesome. So this is my specific starter project. I took the karting project, I expanded on it. When you first start, you will just have a little ring. And then I went and I updated the level design, added tons of gameplay interactions, added AI. You know, some of the things I've added specifically is on the, I've added adjusting gravity, kind of like Mario Kart, where you go off a ramp and you'll flip upside down, you'll ride on above buildings and stuff. I've added action cameras, kind of like from the Burnout Paradise game, when you go off of certain ramps, the camera will slow down and it will go to the side and watch you land. And the AI characters, I did not use Unity's mod version for mine specifically, but that one works decent as well. So I recommend doing that if you want to add AI characters. But there's several ways you can go back. Sorry, there's several ways you can use these projects though. So specifically, if you want to focus on level design, create crazy level gimmicks, kind of like my gravity system, and then continue to iterate and iterate. So when I first started making levels, they were all pretty basic. As you explore more and you come up with new ideas that are just wacky, it allows you to kind of find even more interesting challenges for these. Some of the gameplay interactions you could look at takedowns, for instance. Like if you run into a cart fast enough, maybe they get knocked out and they're out for 3 seconds. You can look at adding power-ups, whether that be Mario Kart style power-ups or even like speed boost pads. You can actually add a track builder if you wanted to for users. This is something I did for a Geometry Dash game, as I made a level builder for users. And I also made an internal one for developers so we could actually just draw our levels on a pixel editor, import it, and it would create our levels for us automatically. You could add multiplayer support, things like that. These start packages, you can actually use them for even practicing other things besides what's listed here. You could do monetization design if you want to. You could do systems design, which would be like maybe like a full-on upgrade system or an inventory system. You could work on balancing or even specific characters. So if you create AI, but you want every character to act slightly different, have different levels of aggression, you could build that. So these are really good if you want to add some to your portfolio, though, specifically because you don't have to create a whole karting video game just to add something for level design to your portfolio. If you want to say, hey, look how good I can create a level, you can go through buildings or anything like that. It really saves a ton of time. So all of these features took me about 4 hours. It'd probably take most people a little bit longer. Obviously, I specifically do challenges where I rush through recreating games in 12 hours if possible. So most people would be a little bit longer, but it shouldn't be too bad. All of these were pretty achievable. But with that, we can actually go to the next slide. Okay, and now I'm actually going to teach y'all how to go through Unity and create a mini map yourself for the karting macro game. It would also work well for the FPS game, but let me just go ahead and share my content.
Zach, quick question in the chat about the starter projects. Do they work out of the box? So like once you load it up and do the install, you can just like immediately start interacting, playing around the environment and start moving stuff.
Yes, they start directly out of the box. They have a few demo scenes actually. Like this karting macro game has a scene that is somewhat similar to this. It's just a ring. You hit start and you can play it. They also have a scene in here where you can like test every single kind of ramp they have in their files and stuff like that. Or you can create your own level from scratch if you wanted to. I specifically just took the level they had that's already functional and just edited it a lot. So, but yeah, it does work right out of the box. But cool. Okay. So you can see here, just to run through, you can hit get started on the right side. Let me save my scene changes real quick. All right, and it'll pop up. It gives a little tutorial of what to do. You can hit start and it'll show you how to actually play the game. And over here, it'll give you like controls. Lessons after this, it'll actually teach you how to change the top speed and the acceleration and things like that on the cart. So that's right here. But there we go. But what we're going to do, what we're interested in is actually making a mini map. So real quick, I can show you my specific level updates in Engine. All right. So I added a quick debug menu here. These will not be here. This is something I specifically added, wrong teleport spot, to just make navigating the level quicker for this demo. So I have this little like crazy spin around loop. You come off here and all of a sudden you're on the ceiling. We can come over here. Here's the action camera. And then we have just some crazy twisting sections here that are really tough with AI. I've turned the AI off specifically for this demo, just so we could see everything. But the great thing about the Minimap is it can be easily expanded on the way we're going to do it. It's going to be easy to add like different Minimap icons. So let's say you have like a power up and you want to give it an icon on the Minimap, you can do that. And for the specific prototype of this, you won't need any code for the Minimap. So to get started, we're actually going to click on all of our track pieces, which I've put underneath this object. We're going to make sure that we put them on track, the layer track up here. If it asks you if you want to set all children to track object as well, you'll hit yes, change children. We're doing this so that we can create a camera that only renders the track on our Minimap, which we're now going to create a camera. So we're going to right click over in the hierarchy. We're going to go down to camera. We're just going to name this Minimap camera. And we're going to attach this to our player, which is right here. We're now going to go ahead and change some of these values that are in here that are kind of crazy when you start. We're just going to set them to where it's on the X and Z axis of the player, but we want it to be really high up in the air. So we're going to set that to 75, and we're going to make it look downward at the player, which is going to be 90 degrees. You can see right here, the Minimap camera is starting to already kind of show. We want our clear flags to be a solid color. So skybox, it'll actually render the skybox obviously in the background. Solid color will render like a blue or something like that in the background, depending on what you set your color as. Depth only changes every every pixel that changes every frame. And don't clear is kind of like depth only, but it acts a little funky. So you could actually use that for some crazy effects if you wanted to. But we're going to choose solid color, and we're specifically going to set our alpha, which is how see-through something is, to 0. This shows the best results for the background, the track actually showing up well and everything. And we want to set our culling mask. This is what is going to be rendered by the camera. We want it to render only the track, and we want it to render our Minimap visuals. For that, if you don't have that, you can click up here on layer and hit add layer, and you can just add it to the next line, which should be 15 if you haven't edited the project at all. Okay. Next, we're going to actually set the projection to either perspective or orthographic. Orthographic makes everything flat, while perspective still keeps like the 3D view of everything. So set the orthographic, and we're going to set it to a size of 40. Flipping planes is fine, and with that, this is good for now. We will come back to this and add a target texture. All right, so next we're going to create something called a render texture. So this is a image that our camera will render to. So everything the camera sees is going to show up on this image. This is really great for portals. This is actually how portals are done almost always. But you can right click down here. We're going to create, and we're going to go to render texture. And we're going to call this, Minimap demo render texture. Okay, and over here, everything over here should be fine. You can set it to 256, 512, 1080, but for a Minimap, it doesn't take up much space, so I wouldn't recommend going above 256. But all this is great. We're actually going to just go back to our camera, and we're going to drag this render texture into the target texture section. That means this will show whatever the camera sees at this moment, as you can see on this little demo. So functionality is almost there at this point. We actually just need to go ahead and create the UI. So we're going to go up to Game Manager, Game HUD, and HUD, and we're going to click and we're going to add an image. And we're going to call this Minimap. With this, we're going to give it just a basic white circle. This image should be in your project already. And we're going to hold on. We're going to set the position. So we can see here, if you click on it, where it is on the screen. You can click your gizmos for certain objects to pop up on screen, such as the camera, the whole screen view. And we're going to set this to positions such as 350 and -150. And we want this to be a width of 175 by 175. Nice and big. There we go. We're going to set the color to kind of like a gray, but we also want to be able to see through it. So we're going to set this to about like 140 or so. Next, we're actually going to add one more image underneath this. So right click on Minimap, go to UI and click on Image. And for this, we're going to make it the same size, which is 175 by 175. And I created this little border image. It's just a ring. We can drag that in, just a nice little border for our Minimap. And all that should be good. The only thing left is to give the Minimap a component called mask. This makes sure that nothing can be seen outside of this. So if the Minimap is like bigger than this, it'll actually be cut off by the circle. Next, we're going to add one more image. We're going to call this one Minimap image, and we're actually going to drag on the render texture. Oh, sorry. We're going to delete this. Whoop. We're going to create a raw image. Raw images work with render textures specifically. So we can do that. We can leave that named raw image. That's fine. We'll set it to the same size. And then we're actually going to drag on this render texture we created. That is the map view. And there we go. We got to make this a little bit larger. And that's a super basic breakdown of how that works. So we can go ahead and hit play. And everything works great. So the only other thing we're going to add real quick is we're going to add a little icon to our player. This will actually allow us to see where we are or where other objects are specifically. So we're going to go to the player. We're going to right click on the player and we're going to go to UI and we're going to create a canvas. We're going to change the render mode to world space. This allows it to actually not be on a flat plane, but in the environment as a physical object. And we're going to make the event camera the Minimap camera. And for the layer, we specifically want it to be a Minimap visual. Once that's created, we can go and we can create an image underneath this by right-clicking, UI, image, and we can just give this any kind of icon that's already in the project. Right now, I'm going to choose the notification icon. And we're going to set the rotation of the canvas. We need to change the position of this. So we're going to set it to 0, 0, 0. We're going to set the Y position actually at 70. That way it's way up in the sky. And a rotation of 90. And there we go. That allows it to pretty much lay flat above the player. as you can see here. Now we are going to shrink it a little bit. So we're going to go to image. We're going to set it to be maybe 15 by 15. We can look at our camera and see what that looks like. And now, when we start, we have our little player icon, and it follows us around. And you can actually take this object. We're going to call this the Minimap Indicator. We're going to drag it down into our assets. This makes something called a prefab. The awesome thing about this is we can actually drag this on top of anything. So we're going to click on our finish line. We're going to grab our Minimap Indicator. What was the object? Start line finish. There it is. You can actually drag this on here, and we can just change the icon to be anything. I have this quick little finish line icon I made that we assign. And then we set this camera to Minimap Camera. And with that, the finish line actually now has an icon as well. And that's a super quick breakdown of how to actually do a minimap, minimap prototype in any game. As you can see, everything worked great. And you can continue and build on that, and you can put those indicators on any object. So with that, we can actually go back to the slides. Does anyone have any questions real quick? Awesome. All right, we can go to the next slide, where we're just going to talk about a recap. So to go over again, make sure to find the project that interests you most. In this image, you can actually see a little snippet of the 2D platformer starter pack. It kind of acts like a little brawler game, possibly. A lot of potential there, a lot of fun. Make sure to use the Unity Hub for your version and project organization, and then follow these tutorials really closely, and use the mods that you can install a lot to really get a handle on what you can do in the project. And then don't be afraid to get your hands dirty and actually code in some of these features. You know, there's a lot you could do with this minimap if you were to look up a few features and how to possibly program it online. And you could really take this next level. So there you go. Any questions?
At this point, are we taking general questions? I wasn't sure if there was anything after this slide.
The only thing we had after this was the mentor check-in, and then the recap. Just a real quick recap.
Gotcha. So that I do have some questions, since I have a game idea in mind. But the more general question I'll just share with everybody, or I'll ask for the benefit of everybody, is, you know, for all the teams, to all the mentors that are on this call right now, you know, in your experience, what is the fastest type of game to prototype? Or does it kind of just depend or not matter, or really just whatever follows the existing or is in the Unity asset store? And so yeah, how do you mean? How do I mean? I guess for myself, the vision I had for my game / story that I want to tell is more of 2D, have a lot of particular images that I'm not sure I can really prototype out super quickly in a 3D model. And I did a quick search during this webinar in the asset store for 2Ds, but I kind of see only platformers. And I wasn't sure if, you know, if you guys are familiar with maybe a terminology that I should be searching, or if it's supporting things. Because like, if you think about it, or if you think back during the Adobe Flash days, those Flash games days, that's the type of thing that I'm kind of looking to build. Now, is that something that Unity supports?
Totally, yeah. So I've actually worked in a couple of games kind of like that. A big thing is you just really got to learn the UI system and figure out, okay, this button does this. I want it to do X, Y, Z. You'll do that in the 2D side of stuff. You might want to look at like point and click games or like text adventure games, that kind of stuff. Because for the life of me, and I can't tell you why, the first game that jumped to mind when I thought of this was like dating sims kind of look, right? And
Honestly, is that far off?
Worst of all, the one that came to mind was the KFC one.
Oh, right.
Yeah.
You want to share the context of that one to everybody?
You want me to share the context of you're trying to date Colonel Sanders in a
Oh,
ridiculous
that's
game?
right. Yeah, that's what it was. Oh my gosh.
It's I don't know why that is what came to mind when you're talking, but yeah, you can totally create that kind of stuff. It's going to be a lot of UI work. Unity has pretty good UI documentation. They've also got a couple different systems. So they've got a new system that runs on kind of more like a CSS. It's called USS, which is Unity style sheets and all this other stuff that you can look at that they're trying to move into. There's a lot of examples out there. There's a tank game that kind of goes over the new UI system if you're interested in that. Can't think of the name of it for the life of me right now.
Awesome, good deal. I
Tanks.
think
It's
honestly
literally
the dating
tanks!
system.
Exclamation mark.
Yeah. All right, cool. Well, I think honestly the dating sim template was probably the closest one, so I appreciate you bringing that up to my attention.
Real quick to answer James' question. So something that wasn't in the quick tutorial I made is the main camera. I actually turn off the layer that renders minimap visual. So it renders everything in the scene except minimap visual. So you can't see them from the main camera. This is a tactic that's used a lot for UI. Some people will have two cameras, one specific for the scene and one specifically for UI, and the UI camera always renders on top. But they turn off rendering UI from the main camera. So that's how you kind of resolve that.
Cool. All right, my next question. This might be a little bit far ahead because this is rapid prototyping, but for something that you have a great idea, but then potentially want to see avenues of building upon it further afterwards. What is the best way to protect your IP, intellectual property? Considerations that you should be taking just from the beginning in terms of if you want to monetize it in the future.
Get a lawyer. I've always lived under the umbrella of anything I'm working in a game jam. If it's a concern with IP or any of that kind of stuff at all, typically just don't work on it then, unless you're willing to disclose it. However, I know the typical statement is if somebody's concerned about IP and all this stuff and they're unwilling to talk to people about what their game is, they're not going to get the help they need to make it happen. So a game that you're unwilling to possibly just talk to people about for IP, like, is going to be really hard to get any help with. So
also, most IPs are not really developed from a game jam either. You can look at Celeste. Actually, Celeste was a game jam project originally, and they took their prototype and they actually made a full game out of it a couple of years later. So typically, your game jam submissions are safe. There's not very often that you'll have like an IP issue, if ever, with a game jam. Something else you can consider is just reskinning some things. So for the game jam specifically, so let's say you have like this really awesome character, and you want to protect that character, you could actually just swap out the character for the game jam specifically, and then put it back into your game as you expand on it. But I wouldn't foresee it as an issue.
I mean, you're moving at such a fast pace, that you're really not going to dive into your experience. You're not going to really dive into really the capabilities that are going to really till much later when you have more time. You're just moving at such a fast pace that you just don't really have to be concerned about the over.
Along those lines, in this sort of discussion, then is one consideration then for people that are building their submissions, like think about a very small number of features you want to demonstrate in your submission. Is that a good thumb rule? Because I mean, I kind of think of this whole, like, I think of the whole challenge as a rapid prototype, right? How do you get there faster?
Mm-hmm. When I've worked with other teams for stuff before, you always get teams starting off and doing game dev stuff going, I want to make an FPS shooter that's got portals and this and this and this. Typically just the best word of advice, especially for 24 hours, because I'm talking about teams that work for 3 months or 3 or 4 weeks to months to whatever, is the statement is always, what is your key mechanic? Work on that. Once you do that, is perfect. It's exactly what you want. Then move to other stuff, because if the core mechanic isn't fun and good, the game won't be fun and good. So
yeah, that's great advice. And I think for folks that are thinking about this from a challenge standpoint, you know, it's not just about, right, your submission. I mean, it's also the idea. There's other factors. And we'll cover that at the challenge review, but I just, I thought that was an important one to address, is just, you know, not getting bogged down. That was one of my takeaways when I watched that first Game Jam video. Among other ones, like, make sure you feed yourself and, like, take care of yourself. So just those types of things, very helpful.
For those of you that are going to work in teams, other just word of advice that I have is, if you're using Unity Cloud or GitHub or something to manage your project and share files back and forth, always keep it playable is my second rule of thumb. If you're going to make a push that's going to break it and not make the game be playable for others, hold off until you can get that figured out. Like, even if it's store the files, just shelve them or something, while somebody else needs some stuff from you. Because that's the hardest thing to deal with, is somebody's working on something, completely breaks the game. I've got to go do something. I can't test my changes until they fix their stuff, which happens 2 hours later. And now I'm 3 hours behind because I have to go back and test my thing and do that. And so just always try to keep it playable is my other word of advice.
Something I specifically do, those 24 hours are done pretty quick. If you do a 48-hour game jam, that's also still very quick. So I always get a baseline vision of the project. I spend about 30 minutes before every game jam I do. I do typically 3 to 4 a year. I spend 30 minutes planning out the project and what is the most important thing to get a playable state. I do that, and then every feature after that is a stretch goal that then usually makes my project a little bit more unique. Specifically, my last game jam project, I made a mobile kitchen game where you kind of drag coffee cups to the coffee maker, then give it to the customer and stuff. But the gimmick was you're actually in the jungle, and all of your meat for food came from your customers, which were animals. So you had to decide like which animals to actually take out in order to get the rest of your food taken care of. I called it Sweeney Todd's Diner. So there we go. But basically just get like a basic version of it finished. So if I didn't get the animal section done, I at least had a kitchen cooking game that was playable.
I know we're a couple minutes over, guys, but this has been a really awesome conversation, and I do want to invite if there are participants that have questions to the panel, if there are any others. I would also say take advantage of the Discord channel, which we'll talk about here in a second. I'll turn that over to Thomas, and then also take advantage of the email address, because everybody that's here is monitoring that. And so if you're trying these starter projects and you just want to figure out, hey, what click do I do for this thing to get there faster, reach out to us. But with that, I'm going to turn it over to Thomas to talk through the Discord.
Yeah, thank you. Yeah, so if you've been on Discord, we have a few channels, and one of them is the Teams channel. That's basically where you're going to go and try to collaborate with other individuals to build your team. What you should probably do after that is once you have a group of individuals that you would like you move forward with, go ahead and contact us through probably the Ask the Question channel. It can actually get you a team channel set up, so you're able to have conversations, jump in over voice over IP, kind of discuss how you're going to move forward, and really leverage Discord as your hub of how you're going to interact. together. And the other channels are pretty self-explanatory. Any mentoring, we have our mentor channel. Please at any of us. I know we'd love to help get involved and kind of help guide the direction that you're headed into. And suggestions in general. If you guys just feel like talking about random stuff, we have our random chat as well.
I would say too, I think it was Kelly at the beginning who said that you had a team. There are at least 3 people, I want to say, that are currently looking for teammates. So if you do get a chance, you may be able to meet some new teammates there and get a sense for like, how they can add to the team, or, just start kicking ideas around.
Okay, cool.
We should get a resources channel in the Discord.
Okay. Any questions on that? And teams and resources? Okay. Well, this was our last topical webinar, but we do have these all up and these archived on the landing page, and you can access the different videos. This one will get posted. We will also share the slides out so you can follow along with the starter project that Zach walked through. And then just a reminder, our last check-in, 30 September, that's 2 Thursdays from now. That's where we'll walk through the actual challenge itself in a little bit greater detail, some of the scoring of that. We will be making a lot of noise because we are going to look at adjusting some of the terms in light of just some of the changes with the conference and the participants and such. But we will look into single-person teams, and we are looking at extending the time frame so that you really do get that Saturday and that Sunday to produce your submissions, knowing that there may be some people working in virtual teams. So those are the couple things we are looking at. We will definitely be sure to make a lot of noise about that. So if you're on the listserv or the email list or the Discord, you'll be hearing all about it. And then just a last call for if you do want to get up on the leaderboard, we've got this sweet Alienware laptop. I know I'm going to be sad to be getting rid of it, but I promise I will ship it to the winner. So just if you get your assignments in if you're interested in that, and help us spread the word because we are just over 2 weeks out from the actual challenge itself. So thank you for taking the time to join us, and hope that you guys are using these to think through, what's my strategy for this rapid prototype that is the Game Jam? How do I get there faster? What tools am I going to use, right? Fail faster. Things we learned today, you can prototype a lot faster than many years ago. So learn the lessons up front, and you guys will be set. And with that, I think we're good. Thank you for everything, Kevin and Zach, in terms of just sharing these tips and for the, for all of you that joined us. We'll see y'all in 2 weeks. Unless do we have any closing remarks from the SASE side, Roland or any of the mentors?
Just basically, thank you to our presenters for showing us and demonstrating these different technologies that we can use. Hopefully our participants will be able to take your tips and figure out how to integrate it into their projects. We definitely look forward to everybody participating and giving a try and demonstrating your skills and talents. And yeah, we look forward to the competition.
All right, everybody. Well, we'll see you guys in 2 weeks, and we'll make sure to get the slides and the Discord links and everything in the recap emails and such so that you guys can interact. But again, reach out at any time, and we'll see y'all in 2 weeks.
Thanks, everybody.
Thank you.
Okay.
Thanks, everyone.
Thanks, bye.
Thank you all.